Okay, guys, welcome. So today we're going to talk about some basic factoring methods. So we're going to talk about GCF factoring. We're going to talk about factoring a quadratic when the coefficient is 1. And of course, with that, we'll also talk about, well, how do you handle it if the coefficient's not 1? And that will take us through some factoring methods. Okay, so one way that you can think of factoring is that it's sort of multiplication of polynomials, but in the opposite order, right? You can also think of it as sort of you're undoing the distributive property. Right? So you're going to be given some kind of polynomial, and we want to express it sort of as, well, what would be like the original distributive property problem, essentially. Okay, so the first type of factoring that we're going to talk about is common factors, right? So what we do here is we look for factors that are common in each term of a polynomial. So for a simple example, let's look at this x squared plus x, right? So it's almost like you're asking yourself, well, what can I divide all terms by? Right, so that's essentially what you're asking yourself, right? And of course, what can you divide each term by cleanly or nicely, right? Now, in this example, you could divide both of these things by x, right? And here you're going to see we're sort of undoing the distributive property, okay? Well, if I'm dividing each of those by x, what would I have left, right? So if you divide x squared by x, you're going to be left with an x. If you divide x by x, you're going to be left with, of course, 1. Right? Or another way that you could think of it is, what would I need to multiply x by to get x squared back? Right? And of course, you would need to multiply by x. What would you need to multiply x by to get x back? Well, that would just be a 1. Right? So we could say that that would be the GCF factored version of x squared plus x. Okay, so let's do a couple more examples of that. So in part A here, we have that 15x to the third minus 10x squared. All right, now let's look at our numbers out front first. We have 15 and we have 10. Now, what can you divide each of those numbers by? Of course, you could divide them each by 5. If we look at our x terms, right, one way we can think of it as would be, what could we divide each of those x terms by? Or you could just say, well, what's the highest power I could take out of both of them? Or what's the lowest power that I see, right? So of course, in this case, you would want to take out an x squared, right? But now we need the rest of it there so that if I were to multiply it together, I would get the original thing, right? So first of all, what would I need to multiply 5 by to get 15? I would need a 3, so I'm going to put a 3 here. What would I need to multiply x squared by to get x to the third? Well, I would need one more x. Okay. Now, in the second term, I need to go from 5 to negative 10, so I need negative 2. And then I need to go from x squared to x squared. Well, I don't need to change anything there, so I could either put times 1 there, or since I already have a placeholder there, we can just leave the 2 there. All right. Now, as a check, let's use the distributive property and see if we get the same thing back. So if we distribute, do we get the original? And of course we will, because if we distribute, we get a 15x to the third minus 10x squared, right? Which is what we started with. So that's a quick way you can check. Okay, let's look at part B. In part B, we have 4x squared times y minus 8xy squared plus 6xy. Okay, so one piece at a time. Let's look at our numbers out front. We have a 4, an 8, and a 6. So it looks like I could take a 2 out of all of those. Then I have x squared, x, and x. So it looks like the best I can do there is just an x. Let's maybe use a different color. Okay, and then for my y terms, I have y squared, and y. So it looks like the best we can do there is y. Okay, now we need to put, well, what we need to go there in order to get the original thing back. Okay, so to go from 2 to 4, I would need another 2. Go from x to x squared, I need an x. And to go from y to y, I don't need anything else. Okay, then to go from 2 to -8, I need a -4. X to x, I don't need anything, but I will need another y. Okay, and then finally to go from 2 to 6, I would need a 3. And my x and y, I don't need anything else, so we're done here. Okay, part C, we have 4x squared minus x. So it looks like the best we can take out here is an x, right? Because I can't take 4 or anything out. So it looks like what I'm going to have left over is a 4x minus 1. And then for part D, we have a 3x to the 4 minus 9x squared. So it looks like for my numbers, I could take a 3 out. And for my x's, I could take an x squared out. So it looks like we're going to end up with an x squared and then minus 3. Okay. So hopefully those aren't too bad. All right, I want to look at a couple more of these. So in part A, we have 2ab minus 8bc. Well, it looks like I have a 2 can be taken out. And the only variable that appears in both is a b. So I can take a b out. Now, of course, what do I need left? Well, to go from 2 to 2, I would need a 1. But since I also need an a, let's just put the a there. All right, I could say 1a. That's not wrong, but usually we ignore the 1. Okay, go from 2 to -8, I need a -4. And then b to b, I don't need anything, but I still need the c there. Okay, now part B is interesting. Part B, I want you to think about for a second. So we have 2x times x plus y minus 5y times x plus y. All right, now when you see this, you might be tempted to distribute this, okay? But don't distribute, right? Because we're factoring. Right, and when you're factoring, you're undoing the distributive property. So if we distribute, we're only creating more work for ourselves. All right, now the trick to this is we're going to think of this x plus y, of course, is just one number. Just thing in parentheses is one number. Now, if I look at my numbers, I have 2 and 5, I can't take anything out. Then I have an x and a y, I can't take either of those out. But if I think of this thing in parentheses as sort of its own number, that appears in both, so I can factor it out. Right, now what do I need to multiply by to go back to the original? Well, if I want to get 2x times x plus y, I would need to multiply x plus y by 2x. Right, and if I wanted to get minus 5y times x plus y, I would need to multiply this by 5y. All right, now if you don't believe me, just distribute this back, but do it in slow motion, right? If I do x plus y times 2x, then I have x plus y times 2x. And if I do x plus y times minus 5y, I have minus x plus y times 5y. But this is just the same as this, right? So if you see those things in parentheses that are the same, we just factor those right out. Right, part C, we have 3r squared t minus 15t squared u plus 6st to the third. So it looks like we can factor, if we look at our numbers, we can factor a 3 out. If I look at my r terms, we have r squared, and that's it, so we can't factor that out. We do have a t squared and t to the third, so it looks like I can take a t out. And then I can't take a u or an s out. So it looks like the best we can do is 3t. All right, so to get 3r squared t, I would need an r squared. To go from 3 to negative 15, I need a minus 5. I'll need one more t, and then I'll also need a u. And then to go from 3 to 6, I need a 2. Looks like I need an s, and I also need a t squared. And of course, if you FOIL that, you will get the same thing. Okay, now part D, similar to part B, where the only thing that's common between these two terms is the expression in the parentheses. So that's what I'm going to factor out again. And then, of course, what do I have left over? I have 3m minus n. All right, so that's part D. Okay, so that's GCF factoring. Okay, now the next type of factoring that we're going to talk about is what if you have something that looks like x squared plus bx plus c, right? And what I mean by this is that your highest power is x squared, but that term specifically has a coefficient of 1, and then the term in front of the x can be whatever, and the constant term can also be anything. All right, so what we're going to do is we're going to open up two parentheses that are of the form x, leave a little bit of room, x, leave a little bit of room, right? Then you're going to look at the factors of c. You're going to look at the factors of your last number, right? And you're going to choose the pair of factors that would multiply to c and add to b, the middle term, right? And whatever those two numbers are, that's what you're going to complete the parentheses with. All right, so let's do a couple of examples of that. So in part A, we have x squared minus 7x plus 10. Right? Now, in this case, your b term is negative 7, and your c term is 10. Okay? So let's look at our factors of c, which in this case are factors of 10. Well, if you want to multiply to get 10, you could have 1 and 10, or negative 1 and negative 10. Right? You could also have 2 and 5, or negative 2 and negative 5. Right? And that's it. Now, out of these choices, we want to pick the two that add up to negative 7. And of course, once you do that, it'll be these two numbers here. So since it's negative 2 and negative 5, remember, we're going to have two parentheses that look like this. And then we're just going to punch those numbers in there, minus 2, minus 5. And that's the factored version of this polynomial, right? And of course, to check, if you multiply this out, you're going to get x squared minus 5x minus 2x plus 10. But of course, once you combine like terms, you're going to get x squared minus 7x plus 10, which is what we started with. Okay, so let's burn through a couple more of these. So we'll go a little quicker. So in part B, we have x squared minus 3x minus 4. Okay, so if we look at our factors of negative 4, we have 4 and negative 1, or negative 4 and positive 1. We also have 2 and negative 2. All right, so of course the one that works here is negative 4 and 1. So this will be x minus 4, x plus 1. Okay, part C, we have x squared minus 11x plus 24. Now, of course, when you're looking at these factors of C, you'll start to get better as you do a couple of these. You'll start to see sort of which number combinations would make sense, right? So, of course, 1 and 24 is not going to do the job. We're negative 1 and negative 24, right? But you could go for something more in the middle. So let's just say you first tried 6 and 4, and then negative 6, negative 4. Now, that's close, but it doesn't quite get us to negative 11. So another one that's close by is 8 and 3, or negative 8, negative 3. And of course, once you find the one that works, you don't need any more, right? So it's -8, -3. So in this case, we get x minus 8 times x minus 3. Okay, part D, we have x squared plus 6x plus 9. And you'll find that this is just going to be x plus 3 times x plus 3, which is, of course, x plus 3 squared. Right, and you could also see that this is one of those special factoring formulas, right? The first number is a perfect square, and so is the last number. And if you take the square root of each of these, the middle term is 2 times their product, right? You get 2 times x times 3, you get 6x. So you could see that with the special form as well, but I think it's easiest just to sort of continue this method. Okay, and then finally, part E, we have x squared minus 2x minus 8. Okay, so for -8, we could do 4 and -2. That won't work, but -4, +2, of course, will. So this is x minus 4, x plus 2. So that's part E. Okay, so hopefully that's not too bad. Now, if you do this factoring and you get to something that you can't factor, that is possible, right? It is possible to end up with a polynomial of that type, and those are called irreducible polynomials. So for example, let's just put one up here. Let's say if you had something like x squared, let's see, plus 7 plus 20x or something. All right, now your only way you could get 7 would be 7 and 1, or -7 and -1. But neither of those add up to 20. So since that happens, this is irreducible. All right, so it is possible that that happens. So just keep that in mind. Okay, so the next factoring method that we're going to talk about is factoring by grouping, right? And this is most commonly used when you have 4 terms, okay? So you're going to group the first 2 terms, group the last 2 terms with all their signs included, so plus and minus and everything. And then you're going to put a plus in between them, all right? Then for each set of parentheses, you're going to do GCF factoring, right? And once you do that, you're going to hope that whatever's left matches. And if it does match, you're going to factor that thing out, all right? And if not, you see if you could slightly tweak the factoring or maybe reorder the terms to get a match, right? So let's look at an example. So let's look at part A. So we have 2ab plus b plus 2ac plus c. All right, so I'm going to group the first 2 terms, group the second 2 terms with all their signs, and we're going to put a plus in between them. Okay, now we're going to GCF factor. If I look at this first expression, looks like I can factor a b out. What would I have left over? I'd have a 2a plus 1. Now in the second expression, it looks like I can factor a c out, and I'll have a 2a plus 1. Well, now the things in these parentheses match. We have 2a plus 1 and 2a plus 1. So I'm going to factor out that 2a plus 1, sort of like we did before. And then what do I have left? I have b plus c. Right? So that's factoring by grouping. So in part B, we have 2x minus 4x squared times y minus 3y plus 6xy squared. Okay, so we see we have 4 terms, so we're going to try factoring by grouping. Let's make sure that we get that minus in there. So minus in there and a plus in between. Okay, so it looks like in my first expression, I can take a 2x out. I'll have 1 minus a 2xy, right? Okay, and then in the second one, let's see if I factor out a 3y. We get a minus 1, and then we get a plus 2xy. All right, now there's a problem here. we're close, but we're not quite there, right? These things don't quite match, right? One is positive 1, negative 2xy, and the other one is negative 1, positive 2xy. But we can fix this. We just need to factor the second one differently, and we just need to factor out a negative. So if we factor out a negative, this is now positive 1, and this is now minus 2xy, so now they match. So now I can factor out the matching expression, get 1 minus 2xy, and then what do I have left over? I have 2x minus 3y left over. Okay, part C, we have a 2m to the third n plus m squared plus 2mn squared plus n. Okay, so it looks like if I group the first two terms together, second two terms together, put a plus in between, I can take a 2m squared out of the first one, and I'm going to be left with an mn, right? Oh, wait, I can't take a 2 out. I can only take m squared. So let's get rid of that 2. Let's just rewrite this. Okay, so it looks like I can take an m squared out. And I'll be left with a 2mn plus 1 plus, and it looks like here, what can I factor out? I can factor out an n. And then I'll need a 2mn plus 1. So again, these two terms match, so I can factor it out. And what do I have left over? I have an m squared plus n left. Okay. Last one in this slide, we have 2a squared minus 4ab squared minus ab plus 2b to the third. So let's group our terms. So group our first two, group our second two, plus in between. So in the first expression, it looks like I can take a 2 and an a out. And I'll be left with an a minus 2b squared. And then in my second expression, knowing that I want to have a positive a, let's factor out a negative b. So that way I have an a, and then I'll need a minus 2b squared. Okay, so they do match. So now I can take the a minus 2b squared out. And then what do I have left? I have a 2a minus b left. Okay, so that's factoring by grouping. Okay, now the last type of factoring that we're going to look at is, well, what if in the factoring we did before, right, where you have x squared plus something times x plus something else, what if instead of x squared, it's something times x squared? Okay, so now there's 5 steps, all right? First, you're going to find what a times c is, so your coefficient of x squared times your constant, and you're going to look for 2 factors of that product that add to b, all right? Now, once you do that, you're going to write the middle term bx in terms of the 2 factors that you found in step 1. And then you're essentially going to have 4 terms, so that's going to suggest itself to factoring by grouping, right? So that's what we're going to do. All right, so let's look at this. So in part A, we have 3x squared plus 7x plus 4. Okay, so step 1 is to look at a times c. So we have 3 times 4, which is 12, right? Which was coming from 3 times 4. And I need 2 numbers that add to 7, but multiply to 12. And of course, those 2 numbers are 4 and 3. Right? So step 2 is I'm going to leave 3x squared and plus 4 alone, but I'm going to write 7x as plus 4x plus 3x. All right. Now I have 4 terms, so step 3 through 5 is essentially factoring by grouping. So I'm going to put these first 2 together, second 2 together, plus in between. In the first expression, it looks like I can take an x out, and I'll have a 3x plus 4. And in the second one, I already have 3x plus 4, so I'm just going to factor out a 1. And now when I factor out that 3x plus 4, I have x plus 1 left over. Right? And of course, to check it, we'll check this first one just to convince you that it works. If you factor this, you get a 3x squared plus 3x plus 4x plus 4, which once you combine the middle terms, you'll get 7x, which is exactly what we started with. Okay, so let's burn through a couple more of these. So part B, we have 6x squared plus 5x minus 4. So in this case, my A times C is negative 24. And what are two numbers that multiply to negative 24 but add to 5? Those two numbers are 8 and negative 3. Right, so I'm going to write this as 6x squared plus 8x minus 3x and then minus 4. So now I'm going to factor by grouping, plus in between. Looks like in the first part I can take a 2x out and I'll be left with a 3x plus 4. And then in the next part I'm close, but I just need to factor out a negative 1 to get my 3x plus 4. So it looks like I'm going to get a 2x minus 1 times a 3x plus 4. Okay. So for part C, let's try to separate that. So part C, we have 3x squared minus 16x plus 21. Okay, so now here, if I do 3 times 21, that's a 63. And it looks like if we do negative 9 and negative 7, that will give me a product of 63, and it will also sum to negative 16. So we can now say that this is 3x squared minus 9x minus 7x plus 21. Right? Now, if you have trouble getting what those two numbers are, just start listing out factors until you find what you need. Right? I've done this about a gazillion times, so it's sort of ingrained in my DNA that you know, these numbers come to me a little bit more quickly. But it's one of those things that will come with practice. Right? But anyway, our next step is to factor by grouping. So it looks like I can take a 3x out, and I'll be left with an x minus 3. And then the next one, I can take out a minus 7, and then I'll have an x minus 3. So once we factor, we get an x minus 3 times 3x minus 7. Okay, part D, we have 2x squared plus 3x minus 9. So my A times C in this case is negative 18. And it looks like the two numbers that I'm going to need here are a 6 and a negative 3. So I'm going to write this as 2x squared plus 6x minus 3x and then minus 9. So factor by grouping. And I can take a 2x out of these two, so I'm going to get an x plus 3. Here I can take out a minus 3, so that way I get an x plus 3. So this is going to become x plus 3 times 2x minus 3. Okay, and last but not least, we got part E, which is 4x squared plus 12x plus 5. Okay, so here if I do 4 times 5 for my A times C, I'm going to get a 20. And I need two numbers that multiply to 20 and add to 12, so that's 10 and 2. Plus 10x plus 2x, and then plus 5. So now when I factor by grouping, in my first two terms, I have a 2 and an x that I can take out. I'll be left with a 2x plus 5. Then the next one is already 2x plus 5, so I'm just going to factor a 1 out again. Both of those things match, so now take it out, 2x plus 5, and what do I have left over? 2x plus 1. Okay, so that's how we can handle the case if our A term is not 1. Okay, let's take a look at another couple examples. So in part A, 4x squared plus 11x plus 6. So if I do 6 times 4, I get 24. And of course, I need 8 and 3 to get 11. So this is 4x squared plus 8x plus 3x plus 6. So let's factor by grouping. I guess I should have included that, but in this case, it's fine because it's already a plus. So I can take out a 4x in the first group, and I get x plus 2. And then in the next one, I can take a 3 out, and I get an x plus 2. So I'm going to take x plus 2 out, and I'm left with a 4x plus 3. Okay, and then finally, part B, we have a 6x squared plus x minus 2. So my 6 times negative 2 will give me a negative 12, and to add to a positive 1, I want 4 negative 3. So I'm going to get 6x squared plus 4x minus 3x minus 2. So factor by grouping. And in the first pair, I can factor out a 2x, and then I'll have a 3x plus 2. And then if I factor out a negative 1, I'm going to get 3x plus 2. So that can come out, and I'm left with a 2x minus 1. Okay, so that's some factoring with that method. Okay, now one thing that I do want to mention before we wrap up is that there's a rule where we should always remove common factors first before attempting any other factoring techniques. This is going to make your life a lot easier in the long run. So I want to do a couple of examples of that. I think this is the last, yeah. So this is the last slide of the examples. Okay, so now in part A, we have x to the third minus 6x squared plus 8x. All right. So again, keeping in mind that we want to factor out any GCFs first, it looks like it can take an x out of everything. And I'll be left with x squared minus 6x plus 8. All right. Well, now this thing that's in parentheses here, this part here, I should be able to factor using what we talked about before. So this x is coming along. Now this x squared doesn't have, it has a coefficient of 1. So we can just build our parentheses right here. And then it looks like I would need a minus 4 and a minus 2. All right, so that's part A. Part B, I have 2x to the third plus 4x squared minus 30x. So it looks like here I can factor out not only an x, but I can even factor out a 2, which is going to make things much, much easier. Because now I'm going to get an x squared plus 2x minus 15. Right? So even though before it looked like my highest degree had a non-1 coefficient, it now does. All right? So 2x is coming along for the ride. And now this part in the parentheses, since my x coefficient is 1, is going to look something like this. So now it looks like I can say that this is plus 5 and minus 3, because 5 and minus 3 will give me negative 15, and if I add them, I'll get positive 2. Okay, part C, I have 3y times y plus 3 plus 2 times y plus 3 times y squared minus 1. Okay, now it looks like I have a y plus 3 in both terms. So I'm going to take that y plus 3 out. And then what do I have left? Well, I have 3y plus 2 times y squared minus 1. All right. Now, if you really want to be fancy here, you can show that this y squared minus 1, if you remember before, those are both perfect squares, y squared and 1. And since there's a minus in between, I can say that this is y plus 1, y minus 1. And that's our completely factored form of part C. Okay. Part D, we have x to the third plus 5x squared minus 6x. So we can take an x out again. I have x squared plus 5x minus 6. So this is going to give me an x times in 2 x's of this form. And then it looks like I'm going to need, let's see. So I want them to add to 5, multiply to negative 6. So we need a plus 6 and a minus 1. Okay, last example, 2x to the third minus 2x squared y minus 4xy squared. So it looks like here we can take a 2 out and an x out. And we're going to be left with an x squared minus 2, or sorry, just minus xy, and then a minus 2y squared. Okay, now this almost looks like something that we've done before, except for this y and this y squared are kind of messing it up, right? So what we're going to do is we're going to pretend for a second that they're not there. All right, so 2x's kind of come along. And if the y's weren't there, then we would need two numbers that multiply to negative 2 but add to a negative 1. And that's x minus 2, x plus 1. All right, but of course, I don't want to just permanently forget that the y's aren't there. But let's think about it for a second. If I want to get a y squared here in this last term right here, the only way that can happen is if each of these are both y's, right? So negative 2 times y, negative 2y times negative 1y, sorry, one more time. Negative 2 times positive 1y would give me a negative 2y squared, right? And of course, if you multiply this out, you will get exactly what we want. All right, so that concludes this video on factoring. I hope you enjoyed, and I will see you next time.